Good evening, everyone. In this class, we will discuss the permutation and the combination previous year question papers from 2011. Yes, if you go through the trends from 2011, there was no permutation combination questions in the year 2012 like that. Okay, but in the recent base 2023 and 2022 and all, some of the applications of permutation and combination questions was there. So therefore, you have to get a basic ideas and a strong knowledge related to the permutation and combination. I hope you people covered the foundation. Okay. Today's class we will discuss the PYQs. So try to understand this question. Study the following figure. A person goes from A to B, always moving to the right, or downwards along the lines. How many different routes can he adopt? How many different routes can he adopt? So this was the actual grid. Okay. So A is here in this corner and B is here in this corner. Okay, one has to go from A to B. The condition has been provided here, rightwards and downwards. This kind of okay, smaller 2 into 2 etc. You people can do the manual things. Suppose if the question is related to the 3 into 3 or else 4 into 4, then it's a lengthy process. Okay, I do not want you to lock up with a lengthier process. Just have the basic idea about how to solve this by using the permutation and the combination. Okay, so that is very, very important. Shall I teach you the permutation and combination, or else you want the manual method itself? You people can say manual method is counting method. You people can count manually. Okay, shall I teach you permutation combination method? Okay, fine. Manual method is simple here. Just you can go here downwards, right? 1, right? So like this you can downwards, and then you can so this is downward, right? You can go in this way also. Okay, you can come in this way also. So therefore 3 here, then 4 here. Straight away you can come in this way. 5 here, then you can come in this direction. So 6 here. So therefore answer for this question is 6. Simple. Okay, just doing the manual calculation you can answer as a 6. But if it is going beyond 2 into 3, 3 into 3, so this is 2 into 3, you people can easily manage. 3 plus 3, okay, 6. Suppose if you are using the permutation and combination, okay, permutation and the combination, how to do these things. So you people please take those things in your notes. So this and all you can't get in regular books. Okay, so therefore you people can take this one. Consider P into Q be a grid. P into Q be a grid with the top left corner A and bottom right corner B. Bottom right corner B. The number of different path available to move from A to B, moving downwards and rightwards. right word is P plus Q, P plus Q, C, P. This is fine because P into Q. Here that grid means the number of rows is equal to number of columns here. Okay, so here P into Q, which means M is equal to N. The number of rows is equal to number of columns. Okay, like a matrix 3 into 3, 4 into 4, 2 into 2. So like that. So these and all matrix. Number of rows is equal to number of column. Okay, you can call this as a square matrix also. These things it is there in your matrix and determinant. Those things not required here. Now, or else you may say Q. Yes, both are same, right? You can use Q or P. Now try to understand this one. What is P plus Q in this case? 2 into 2, right? So 2 into 2 means P plus Q becomes 4. C, the P is 2, Q is 2. You can take anything. So therefore 4C 2. So which is equal to, you know the combination, shortcut and all you learned in your foundation, right? NCR formula, if you want you can use n factorial by r factorial into n minus r factorial. In shortcut you can use. How to use? From 4 you have to move 2 places, not up to 2, just move 2 places, right? Or else you can use that factorial itself. Okay, formula you can use. Suppose if you people don't know these things, means you can use this one, 4 factorial by r factorial, right? R is nothing but 2 factorial, again n minus r, so therefore again 2 factorial. So this is nothing but a 4 factorial is 24. So here 4, you can cancel this one, so which is equal to 6. You can use this method also. So learn this method will help you to solve. Okay, take these notes in your notebooks. Okay, during revision purpose also it will help. Shall we move on to the next year? Okay,
Sir, 2 plus 2 again. Sir, 2 into 2 again.
2 rows 2 columns, 3 rows 3 columns, like that. So this is 2 into 2. So 3 into 3 means like this. Okay, this is 3 into 3 grid, so this is 2 into 2 grid. Getting? Okay.
Getting.
Okay, now let us move on this one. Next problem. 6 identical cards are placed on a table. Each card has numbered 1 marked on the one side. So 1 here, this side, back side marked as a 2, other side. All the 6 cards. So like that, you are having 6 cards here. 6 cards are placed in a manner such that one on the upper side, in all the 6 here. So this was the initial position. Now in one try, exactly 4, neither more nor less, so which means exactly 4, that's it. 4 cards are turned upside. In how many least number of tries can the card be turned upside down such that all the 6 cards shows 2 on the upper side? Now first time you can do this one. So first 4 cards you can turn as a 2 2 2. So remaining remains a 1 1. The second time, what you people will do here is keep any two of the 2s here, any 2 of the 2s. So let us keep any 2, so not an issue. So we can keep this one. Alright. So after keeping this one, or else do one thing. In simple manner you can do. The first attempt you are doing as a first 4 cards, right? Then what you are going to do here is you are keeping, right, one you can keep here. So let us keep this one as a 2. Another one you can keep here. The last one you also you can keep here. Now flip the center part here, center 4. Then it becomes 1, 1, 1. Then here 2. Now third time you can do here. Flip. Right. So here 2 is there, here 2 is there. Not going to affect these things. You are going to flip rest of the things. So therefore flip this one. So therefore 2, 2, 2, 2. So 4 cards only you have to do here. So 3 times minimum, right? Minimum means the least number of times. So therefore 3 times. Or else with 3 tries you can able to change it as a 2, 2, 2, 2. Okay. Shall we move on to the next question? Okay, fine. Yes, sure. Learn this question. 2015 repeated in 2013. Sorry, repeated in 2023. This question repeated in 2023. Okay. Repeated in 2023. Understand this one. I will show you that 2023 question also. There are 5 tasks and 5 persons. 5 tasks, right? Task 1, task 2, task 3, task 4, task 5. 5 persons. Task 1 can't be assigned to either of the person P1 and P2. So therefore this job done by either 3, 4, 5, which means persons, right? So P3, P4, P5. Task 2 must be assigned to either P3 or P4. Right. Now try to understand this part. From this itself you can able to solve this kind of questions. Now try to understand. To complete the task 2, how many ways are there? 2C, 1. Among these 2 people, 1 are going to complete this one. So from this, suppose if 1 completed here, so 1 is present here, right? So then here, how much here? So these also 2C, 1. So then this one 2 tasks completed now. Remaining 3 tasks. So 3 out of 1. Okay. So then here 2 tasks. 2C1. Here only 1 task. 1C1. So that's it. So this kind of things you can learn here. 2C1 2. Here also 2. Here 3. Then here 2. Here 1. Please multiply this one. Please mute. 2 into 2 into 3 into 2 into 1. Multiply. So therefore 8 into 3. 8 into 3 become 24. Okay. That's it. Anybody having doubt means you can ask quickly. Shall we move here to the next question? Now try to understand. The same question here was there. I will show you that question. Wait. Check this question. There are 5 persons P, Q, R, S and T. So 5 persons, right? Each one has to do, each one of whom has to assign 1 task. So therefore 5 tasks totally. Neither P nor Q, right? So here in additionally they are using P, Q, R, S, T. That's it, right? There in 2015 generally they are mentioned as the 5 persons. Here the specifically mentioning a P, Q, R, S, T. Each one of whom as to be assigned one task. Neither P or Q can assign to task 1. Same thing here. So therefore, task 1 can be assigned to whom? R, S, or T. Task 2 assigned to must means compulsorily assigned to either R or S. Right? Now, task 3, 4, 5. Task 2 completed in any of them. Okay, 2 people are there. Among these 2 people, one can pick the task 2. So therefore 2 here. Okay. If R or S present here means in the task 2 means only one among them present here in the task 1. So therefore 2 only present here. 2 people present here to complete the one task. So therefore 2 here. So total 5 tasks. 1 task assigned, 2 tasks completed. How many remaining? 3. So 3 tasks. One only we can assign for the right. One only assign here. Task 3 can be completed by one person. So that only provided here. Whom has to be assigned only one task. One task one. Okay, each one. So therefore 1 here. So 3C1 is nothing but 3. Then so 3 tasks over remaining 2C1. So therefore 2 here. 4 tasks over 1C1. So this is only assigned 1 here. So multiply this. So therefore 24. Getting everyone? Okay, fine. Same question repeated here. Check here. 2015 same question. So therefore please go through the previous year question paper. Very, very important. Okay. Many people will teach you many methods. This is the very simplest method. Okay. You can use this simple method. Now let us move on to the next question. Yes. In a box of marbles, there are 3 less white marbles. It's a kind of arrangement question. So that is why we are discussing here. Okay. Arrangement kind of question. Then the red one and 5 more white marbles than the green one. If there are total 10 white marbles, how many marbles are there in the box? So read the question easily, you can able to understand. In a box of marble, there are 3 less white marbles than the red one. Okay. According to the first statement, what is the? So white is equal to 3 lesser than the red. Next year, second. So what is this one? White marbles is equal to 5 more white marbles than the green one. So green plus 5. Now, if there are total 10 white marbles, substitute here. So what is the red here? Red is going to be the 13. Green is going to be the 5. 5. Green is going to be the 5. The total here is add up this one 28. Okay. Getting everyone? Anybody having doubt here? No, right? Okay. Simple arrangement kind of things also you can do here. Don't do a mistake. I hope you people are getting these things. Now next year. Simple. A bag contains 20 balls. Green your 8. White your 7. Red your 5. The total your 20. Now this is very important. There is a possibility to make a mistake. Okay. What is the minimum number of balls that must be picked from the bag blindfolded without replacing any of it to be assured of picking at least one ball of each color? At least one ball of each color. Okay. Now try to understand this one. Okay. which gives you the maximum here. Maximum. Suppose if you are taking 8 balls, all the 8 may be green, right? If you are taking 7 balls, that 7 also going to be the green. That is the possibles here. So that therefore, if you are taking 7, that might be a white also. So therefore add up these things. So 8 plus 7, 15, right? Minimum, right? So now take up that remaining one minimum. So therefore remaining one is nothing but the other color, that is the red here. So therefore 16 is the correct one. Getting?
No, sir.
If you are taking 8 balls, if all of them are green, fine, 8 here. Understanding? If you are taking another 7 balls, all of them are 7 or white, that is also fine. Next one is going to be your out of this 5 you are going to pick a 1. Since they are mentioning at least one ball of each color, we require only one red color here according to the question, because at least, so therefore add up 1. The question here is minimum number, so therefore 16 balls you need to, right, take here without replacement, assuring that at least one of the ball having the all the colors. Getting, Atul?
Sir, to then to we take 3 also, no sir? 1 1 1.
Huh? How can you say 1 1 1 1? Exactly, you will
So
pick the ball.
at least one of each color, sir.
My question is, you are randomly picking, right? Blindfolder, what do you mean by that blindfolder? Without seeing that bag. Getting?
Yes, sir.
Then how can you say exactly you will pick that one ball as a green, one ball as a white, one ball as a red? Getting?
Okay, sir. Now get it, sir.
Okay, fine.
Sir?
Yes, that mistake was I mentioned. So I have mentioned now there is a possibility to make a mistake. The people will make a mistake as a 13. There is a possibility to make a mistake as a 13. Rest of the things you people will not get up. Okay. Because what is suppose 8 plus 5. Now try to understand 8 plus 5. What is 8 plus 5? 13. So if we need only one means 14. Okay, that option is not there. So there is no possible to make a mistake with this one. Okay. Then 17 not at all possible here. 11 not at all possible. So these two only possible here. Okay. Please try to understand the question. Don't put anything else here. The thing is discuss the question here. What is the minimum number of balls that must be picked here? Okay.
Sir?
Let me complete the question.
Yes, sir.
Sudhir was asking something. Okay. Anybody can say what would be that one? What if maximum was asked? What is the maximum here? What is the total number of balls here?
20.
Sudhir, getting?
20, sir.
Getting a now? Fine.
Yes, sir.
Minimum here. Now listen, why not 13? That we will discuss here. If you are picking 7 balls here, right? All the 7 goes to green also, right? All the 7 goes to green also. All the 7 goes to green. So one green is left here, right? You are picking this 5 here. From this 5, 1 may be a green also. Then other 4 may be a what? White also. Getting? Why not 13 here? Getting why not 13? Dharni. Rakesh, okay. What about the Dharni? Shall we move on to the next question? Okay. Therefore, what you need to do here is pick the maximum one. Pick the maximum, next maximum. That much of minimum number of attempts you have done here. This much of number of attempts you are making. After that only you are picking the next least one. So this is the thing you have to do here. So therefore 16, please be careful. Don't, so see 17 won't be there, 11 won't be there. But you people may get a confusion with 13. That is what by taking this question itself I have mentioned. There is a possibility to make a mistake by marking 13. Okay, please be careful. Fine. Next year. Two boys and two girls are to be arranged in a row so that the girls are not next to each other. How many possible arrangements are there? These things and all you have learned in your foundation. First thing is try to get the possible arrangement of 4. 4 factorial arrangement. 4 factorial is equal to 24. Now they are together. So together means what you people have to do here? Treat them as a single unit. Single unit. So therefore here single unit means 3 factorial. To arrange these scales, which means G1 and G2, that is 2 factorial. Why? G1 G2 or else G2 G1. Okay, therefore 2 factorial. So this is nothing but a 6 into 2 12. The question is not means what we have to do from the total you have to subtract. So the answer here is 12. Getting this we have done in your foundation, as well as the additional videos also we have done in the additional class also. Anybody having doubt means you can ask quickly. I will teach you again. If anybody having doubt. No, okay. We'll move on to the next question. Nowadays they're not asking this kind of questions, but have an idea. Next one. This question you can take it as a puzzle also. Okay, but why we are discussing here means one question was there, how many ways? Okay, how many different ways? Okay, for this one we are discussing another 2 set of questions. Okay, this one we can discuss here, but any other 2 questions we will discuss also like a puzzle. Okay, one question can be answered by using the number of ways also, others also you can use by using the number of ways. Now 8 railway station A, B, C, D, E, F, G and H are connected either by the two-way passages or one-way passages. One-way passages are, so one-way means you can take a one arrow mark. Okay, one-headed arrow mark. Two-way means you can take a two-headed arrow mark. Okay, simple. One-way C2. See, recordings won't be provided if it is not saved. Okay, rest of the things your choice. Don't message immediately recording. If it is saved means we will upload. If it is not saved means surely we can't able to upload. So here C2A one way, then E2G one way, B2F one way, D2H one way, G2C. Now try to understand G2C. So G2C only one way. G2C one way. Next year E2C. E2C one way. E2C one way. Then H2G. H to G one way. Now, two ways passages are A and E. A and E, 2A. G and B, 2A. Then F and D, 2A. Then E and D, 2A. Now while traveling from C to H, which one of the following station must be passed through? C to H. Which one of must be passed? Now try to understand this one. See here, right? C to H you have to move. So only one direction. C to A we can go. Then A to E we can come. Then E to G we can go. Then B, no, not possible. Yes, we can go. E to G we can go. G to B, B to F, F to D, then H. Or else you can go in this way. C to A, A to E, E to D, then H. So E must be there in both the cases. Okay. So the answer for the question is B. E must be there. Okay. Shall we move on to the next here? Okay. Now just have the idea here. The question is same here. Okay. Let us see the question and we'll mark here. In how many different ways can a train travel from F to A without passing through any station more than once? Now F2, please remember F to A, without passing through any of the station more than once. So let us solve this one. F to A. So how many? F, D, then E we go, E to C we go, then A. One option will be there. F, D, E, A. So second option there. Then F, D, H. Then we can go with the G. Then we have to come back to the G means which one we have to come? Check this one. Can we move in this direction? G.
G to C, sir.
G to
Yes,
C
sir.
is there. Yes. G to C and A. So this direction we can go. Final one. Check here. F, D, E. E. Then we can go to the G. Then we can go to the C. Then we can come back to the A. So therefore 4 ways we can use here. Okay. So 4 ways we can use. So next question. Shall I give the next question? Check this one. If the route between G and C is closed, which one of the following station need not to be passed through while traveling from H to C? H to C need not to be passed. So let us move on to the diagram. Okay. So there is no path to the G to C. There is no path to the G to C. So let me complete here. So for third question, no path here. Then need not to go means A you should not go. That's it. Okay. Read this question carefully. While traveling H2C. Check here. So H2C, if you are going means, how can you go? H2G we can go, G2B we can go, right? A need not to B. So therefore we can mark this as a A. Okay. So you people answer as a A. Okay, good. Anybody having the doubt here with this kind of questions? It's a kind of a puzzle also we can take. Okay, not only the permutation, only one question we can take it as a permutation. Okay. Now, shall we move on to the next question? Okay. 2018. This is very important, simple question, but simple question only. A lot of understanding required. For a sports meet, a winner stand comprising 3 wooden boxes in the following form. There are 6 different colors available to choose from, and each of the 3 wooden blocks is to be painted such that no 2 of them has the same color. In how many different ways a winner can be painted? Winner can be painted. This kind of model repeatedly they are using here. Okay, 6, right? P, 3 boxes, right? Simple, 6P3. How to write here? 6P3 n factorial by n minus r factorial. Or else, in a simple manner, move 3 places from 6. 6 into 5 into 4. That's it, 120. Or else you can use NP R formula also. Anything you can use. So 120 is the correct answer. Anybody having doubt here? Done means we'll move on to the next question. Shall we move on to the next question? Okay. So which year? 20. This is also 2018. Okay. Check this question. A bag contains 15 red balls and 20 black balls. The total also you can take here. The total you can take it as a 35. Now try to understand. Each ball is numbered either 1 or 2 or 3. 20% of the red balls are numbered 1. 40% of them numbered as a 3. Similarly, among the black balls, 45% are numbered 2. 30% are numbered 3. A boy picks a ball at random. He wins. This is the question. If the ball is red and numbered 3. So check here. Red and number 3. Number 3 here is 40%. Right? Red. So what is the number of red balls numbered 3? Numbered 3. 40% of 15. 40% is nothing but 2 by 5. 2 by 5 into 15. You can cancel this one. 3. So which is equal to 6. Now read the statement. Next one. If it is black and numbered 1 or 2. 1 or 2. So 1 or 2. Please be careful here. Now how many percentage you will take your 45% for the 2, 30% for the 3. So which means you have to add up that total here. So therefore, a black balls numbered 1 or 2 is equal to totals 45 plus which one we have to take here? 1 or 2? 1 or 2. So now check here. 45% numbered 2. 30% number 3. Then 1 will be what? 25%. Okay. Please be careful here. So therefore 45 percentage plus 25 percentage of 20. So therefore 70 percentage of 20. 70 percentage of 20 is nothing but how many? 14. So therefore probability of winning is equal to 6 plus 14 by the total here is 35. So which is equal to 20 by 35. You can cancel this with the 5 table, 4 by 7. So the answer here is 4 by 7. Okay. So one probability question also here discussed. So now Sudhir understanding, Samir understanding, Atul, Janani, others understanding. Okay. Okay. Next year. This kind of question and all very lengthy question. Okay. Which one you are not understanding? Jerin, Jerima. You can say which question you haven't understand. I will teach you again also, but tell me which part you are not understanding. Or else mark the slide number. You can ask later. Okay, but don't irritate. Mark the slide number and you can ask later also. Slide number 13. Suppose you have sufficient amount of rupee currency in 3 denominations. Rupee 1, rupee 10, rupee 50. 3 denominations. How many different ways can you pay a bill of rupees 107? It's a lengthy question. Looks very simple, but it's a lengthy. Okay, rupee 1. So you just do serial number also. Then only you can able to one, then your 10, your 50. So therefore you can make a possibles here. What we are going to do is first complete the 1 rupee, then come to the 10 rupee, then come to the 50 rupee. So like that you can move, then easily you can able to complete. Now I am completing the first serial number 1 for a 1 rupee. All the 1 rupee I am taking as a, okay, all the 1 rupee I am taking. So therefore 107 rupees I am paying. So therefore I am not using any 10 rupees and 50 rupees. So 1 rupee coin over. Now let us come to that second one. Okay, if you are taking all, okay, as a 10 rupee, maximum you can take 10 rupees. So therefore 7 here. So no 50. Okay, so like this you can use your 9 means you are using 7, 17, right? So like this 8, 7, 6, 5, 4, 3, 2, 1. So therefore you have to do here. Don't bother about 1 rupee coin, etc. When you are using this one, surely remaining you are going to use this one, because we are not using any 50 rupees here. We are not using any 50 rupees. So then don't bother about 1 rupees etc. here. Don't subtract. Just focus with the serial number. So that only we need here. Okay, so 11 here completed. Next year you can go with the 50 rupees here. So 10 rupee. Now we are going with the 50 rupees. Suppose if I am using 150 rupees, right, then what will happen here is I have to use 5 notes here for the 10 rupee, then 7 coins I have to use, so therefore 12. Okay, so like this 150 note, year 4, then year 1, year 3, year 1, year 2, Here 1, here 1. Now here 1, here 0, which means you are using 50 and 1 rupee coins only. So therefore here 13, here 14, 15, so 16, 17, right? Now 1 completed, so 1 rupee, sorry, 1 note of 50 completed. Then if I am using 2 notes of 50 rupees, then I am not going to use anything with the 10 rupee. So 0 here. I have to use 7, 1 rupee. So therefore we can make 107. So therefore 18 different ways are there. Okay. Yes. Bhaskar, you are correct. You can use that one also. Fine. Shall we move on to the next one? Okay. Now 2020, this was the question. How many different sums can be formed with the denomination of rupees 50, rupees 100, rupees 200, rupees 500, rupees 2000, taking at least 3 denomination at a time? They're not bothering about the total here, but the previous question is regarding with the total sum, specifically mentioning rupees 107, but here no such a constraint. Totally how many denominations we do have? Total 6 denominations. So that only you have to check your 6 or 5, 5, right? 5 denominations, 50, 100, okay, 5. Now try to understand. At least 3, this we have done in your class also. 5C3, 5C4, 5C5, that's it. 5C3 can be written as 5C2, 5C4 can be written as 5C1. So these are the properties I explained in the combination video, right? Foundation you have to watch. So here 1, so therefore 5C2 is nothing but 10, 5C1 is nothing but 5, so this is nothing but 1. The total here is 16. So now this property I used NCR is equal to NCR minus 1, provided, right, when you are subtracting this one, the R must be lesser, the resultant must be lesser. Okay, this condition I mentioned. Then I have taught you the properties also. What is NC1? NC1 is equal to N, NCN is equal to 1. These properties and all I taught you, people can done this. Fine. I'm moving to the next question. So this kind of question may repeated, okay, in your examinations. Please be careful. Now on a chessboard, in how many different ways 6 consecutive squares be chosen on the diagonals along your straight path? Okay, the first thing here is you need to have the basic idea about how many squares are there. Okay, because in 2021 there was a chess competition, in 2022 or 2023 there was a, okay, one competition happened in Chennai also. So like that they are applying that one. 1 2 3 4 5 6 7 8. So now 1 2 3 4 5 6. Okay, so consider as a 6 here. So another 2 we have to put. Okay, now they are simply mentioning as a diagonal. Okay, so don't do a mistake of by thinking only one diagonal. Both the sides you have to do here. This diagonal also you have to do. Okay, then this side also you have to do. How many different ways can 6 consecutive? So in a diagonal you do have the 8. Okay, so we can form 6 from the 1. Another 2 is left here, right? 2 boxes left here. So there we can form here by leaving 1 boxes from the below. So 1 here, 1 leaving, then you can form another. So therefore 3 ways you can make in one diagonal. If suppose that option was there, means there is a possibility to mark it as a mistake. Another diagonal also contains 3 here. So the total here is 6. So the answer for the question here is 6. Getting? Anybody having doubt here? No. Okay, fine. So let's move on to the next question. Very important question. Okay, very important question. Lot of things are there to understand this one. There are 6 persons arranged in a row. P1, P2, P3, P4, P5, P6. Another person, okay, has to shake a hand with the 3 of them, so that he should not shake a hand with the 2 consecutive persons. 2 consecutive persons. In how many distinct possible combinations can the handshake take place? Now, try to understand. First case we will do here. Suppose if I am handshaking with the P1, then I have to do here, then I have to do here. This is first case. Second case. Suppose if I am doing the handshake with the first here, 2 consecutive only, right? So now I am not going to do a handshake with the P2 and P3. I can do a handshake with the P4. I surely can't able to do with the P5. Then here P6. Now 3 here. I am doing it with this person. I am not doing with this person. I am doing with this one. 2 consecutive, right? So I am leaving these 2. Anything. Okay. Now 4th here. I am not doing with the first person. Then second one. Then surely this is not this person. This is not this person. How many ways are there total? 4 ways are there. Distinct possibles. So therefore 4 is the correct answer. Anybody having doubt here? So in the examination, all possible that to make a mistake. After that, you people surely will do, but no
Sir,
effort. X.
can there is a possibility that person P1 and P2 are left while
P2 and
P1 and P2 are left?
then you can't do the handshake with the three persons.
Yes, sir. Understand, sir. Now understand.
Okay. Next year. Same kind of arrangement. Okay. The letter A, B, C, D, E are arranged in such a way that there are exactly 2 letters between A and E. How many such arrangements are possible? How many arrangements are possible? So therefore total 5. Okay. Total 5. There are exactly 2 letters between A and E. Okay. So then this is the first case I am taking here. Total 5. 2. Then I am placing A here. Then 2 people. Then E here. Fine. Completely fine. This can be done in the reverse way also. So that you don't forget. E can be here. A can be here. This is very important. Okay. With the first 2 cases, if you are doing, means there is a possibility to make a mistake as a 12. That is wrong. This case also you have to do here. Okay. E can be your A here. Total how many? 4. To arrange A and E, we do have the 4. To fill this rest of the places, we do have the 3 factorial ways. Okay. Getting why 3 factorial? So here 4. This is 4. This is 3 factorial. Remaining 3 people are there. So they can be filled here. So here 3. There is a possible here. 3, 2, 1. So therefore, for 1 itself, right? For 1 itself 6. 4 such arrangement are there. 4 into 6, which is equal to 24. So in any situation, if you are marking this alone, means the answer becomes 12, then it becomes wrong. Okay, don't do a mistake. Check with the E position also. If A present in the first position, there is a possibility that E can be present in the first position. So this and all you have to take it while solving the question. Okay, shall we move on to the next? How 6 are? How 6 are? Okay, fine. Listen. So A and E, remaining B, C, D. To fill this one, how many options we do have? 3 options we do have. 1 done. Then to fill this one, how many options we do have? 2. Then to fill this one, only 1. So therefore, the first case here is nothing but 1 into 3 into 2 into 1. So which is equal to 6. So then the second one is nothing but 6. The third one is nothing but 6. The fourth one is nothing but 6. The total here is 24. This is also fine. If you are doing manually, cases also if you are doing means that is also fine. Getting a? Okay, fine. Next year. A, B and C are 3 places such that there are 3 different roads from A to B. 3 different roads from A to B. So this and all we are done in the very basic foundation of permutation. Okay, arrangement. 4 different roads from B to C. Okay, B to C. 3 different roads from A to C. Now, in how many different ways can one travel from A to C using these roads? Now try to understand, this is direct 3. Now here, how many ways? 3, here 4. Multiply this one, M job and N job, both the jobs. So therefore M into N becomes 3 into 4, 12. The total becomes 15. Getting everyone? Okay. Next year. So this is 2022. So this is also 2022. Okay. So very important model. Okay, this is a time consuming. There is a possible to make a mistake if you are doing, if you are missing one, then creates a impact. So that is why the people say 2022 is the toughest. Okay, because of the lengthy question paper. Okay, now try to understand this one. 3 persons A, B and C are standing in a queue, not necessarily in a same order. There are 4 persons between A and B. Now first statement I am taking, I am just doing the arrangement. 4 persons, right? A, 4, B. So this is one case here. Now try to understand the reverse also possible. Okay, A, 4, B. So next is going to be the B, 4, A. So this also possible. Next year. And 7 persons between B and C. So if you are using the first one, what will happen here? Okay, if you are using second one, what will happen here? So that only you have to understand here. 7 persons between B and C. Okay, B and C. So here I can take this also. 7 persons here. Here C. This is one case. I am taking this here. Okay, so this is B here. Then which one we can take here? A, 4, B, then 7, C. This is fine here. Okay. Next here. Anything else possible here? Anything else? This is one. This is second. Okay. Third. Anything else possible? You have to check here. Now, let us move on to the next here. If there are 11 persons head of the C, 11 persons head of the C. Okay. Now, try to understand, is there any possible? Now, let us take this one. If you are taking A here, right, then there is a 4 people between A and B. Now, try to understand. This case is very important. Okay, that is why I am explaining this case. 7 persons, right, between B and C. Here 4, here 5, then another 2 persons also possible here. Then we can place a C here. Getting? Now check in this case. First case. 4, 5, here 2, here C. This is also possible. Hope you are getting these things. That is why I am using the different color. Now, next one. There are 11 persons head of the C. Head of the C. So 11 here. Now check here. Head of the C. This case whether possible or not. 7 plus 4 itself 11. When you are adding this one, then become 12. If you are adding this one, this become 13. Head of the C, you are having 11 only, but it is going beyond 11. So therefore, eliminate this case. Now, is there any possible here? Yes, this is possible. 11. Head of, right? Let us check here. 3, then 7, then 8, then 3 we have to put. Okay. So now, move on to the 13 behind A. 13 behind A. So here, how many here? 5 here. So therefore, we have to put 8. Now, put a 13 behind A. So now, A is there. Now, 3 is there means, 3 means 2 plus 1. See, therefore, 3 people. We need a 13. So, another 10 here. Now, add up this one. We have done these arrangements. Now, add up this one. If you are adding this one, 8, 9, 10, 14, 14, 14, 16, 17, 17 plus 11, 28. Now this one. Check whether minimum, right? What is the minimum number of persons in the queue? If it is goes beyond 28, leave that one. Check this one. 20, here 11, 31. So leave that one. Because it goes beyond 28. 28 itself a minimum. If it is goes beyond that one, leave it. Now we have to check here whether it is lesser than 28 or more than 28. If it is more than 28, then we have to take a 28 as the answer. If it is lesser than the 28, then we have to take this one as the answer. Now let us check here. 10, 11 plus 2, 13, 14, 18, 19, 19 plus 3, 22. So, what could be the minimum number of persons in the queue? The minimum number of persons here is 28 or 22. In this case, 22 is the minimum. We have to take the minimum. So, the answer for the question here is 22. Getting? No other way. It's a lengthy question paper in 2022. Next year. This is also lengthy. Okay, but it has a lot of things to understand in this question also. There are 9 cups placed on a table, arranged in an equal number of rows and equal number of columns, which means that it is a square matrix. Okay, please try to understand. So 9 can be written as 3 into 3. So that is the square matrix. Okay, which contains 6 cups contains coffee and a 3 cup contains tea. In how many ways can they be arranged so that each row should contain at least 1 cup of coffee? At least 1 cup of coffee. Okay, at least 1 cup. At least 1 means minimum 1. Maximum it can go with a 3 also. Okay. So now let us move on with the cases here. Case 1. Now you can take this case here. Okay. What we are going to do here is least 1 year. Okay, least 1 means minimum. So then I can place a 2 also. I can place a 3 also. In this case, the remaining T. Okay, because after making the arrangement, you have to check whether it contains the 6 cup of coffee and a 3 cup of tea. Yes, after making the arrangement, we can see that a 6 cup of coffee and a 3 cup of tea. Next here. So this can be arranged. 3 cup of coffee arranged in the one row. So therefore 1. Okay. Then 2 cup arranged in. So this row can be arranged in 3. Why 3? CCT, CTC, okay, TCC. So that is why 3 here. So here, same here, 3. Getting why 3? C, TT, C. So TCT, TTC. Okay, that is why 3 here. Okay, now try to understand. So this is nothing but 1 into 3 into 3. Now this can be arranged in 3 factorial ways. Why? Suppose for example you can take this first row as a second row as a B, then this as a C. Okay, this A, B, C, A comma B comma C arranged in 6 ways. Why? A, B, A, C, B, C. Getting this point here. How can you arrange these things? In a 3 factorial ways. 3 factorial is equal to 6. Getting a, don't do the manual calculation etc. Just do this one 3, right? 3 factorial ways. 3 factorial here is nothing but a 6. Getting, or else if people need a manual calculation also, or 3 factorial fine. Okay, fine means okay. Now in a case 1, 3 factorial into 1 into 3 into 3. Okay, 3 factorial is nothing but a 6. 6 into 9, which is equal to 54. So this is with respect to the case 1. 54 is the present in the option. Don't do in every situation. Now case 2 is anything possible. So let us check with the case this also. We need a 6, right? So you can arrange CC, CC, CC. We can arrange TT, TT. Okay. 6 cup of coffees are there. Then 3 cup of tea also there. Condition here is at least 1 cup of coffee. Right? At least 1 means maximum here. So then we can use this one. So this is 3 ways. This is 3 ways. So this is 3 ways. So therefore 3 into 3 into 3, 27. The total here is 54 plus 27, which is equal to 81. So the answer here is 81. Okay. Next year. 2023. Same kind of question. Okay. 2021 you got a chess board kind of question. Here they are asking you simple arrangement. What is the number of selection of 10 consecutive things out of 12 things in your circle taken in a clockwise direction? So mark here 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have to take here, right? Listen, 10 things. So we can take 1 to 10. right? Then 2 to 11, then 3 to 12. So like this, okay, how many times you can able to make? So we can able to make 12 times. Number of selection here is 12 times. The answer is 12. Getting a so we need 10 only. Okay. Okay, fine. Next year. So same thing here. This kind of things you can take it as a series kind of question also, arrangement kind of question also, anything, whatever you can take. Just understand the concept here. 40 children are standing in a circle. One of them, say child 1, as a ring. The ring is passed in a clockwise direction. Child 1 passes to the child 2. Child 1 passes to the child 2. Child 2 passes to the child 4. Child 4 passes to the child 7. So now you can see some pattern here. 1 plus 1, 2. 2 plus 2, this one. 4 plus 3, this one. So next is going to be the plus 4. So 11. Next is going to be the plus 5. Okay. So which is equal to what? 16. Next is plus 6. 22. So next is plus 7. 29. Plus 8. 37. Okay. Next plus 9. Now try to understand 40 children only, right? So 3 goes to the 40, then next is 6 here. So again it goes to the 6th child. Okay, this is the very important thing. We have to check. Again it has to come to the child 1. Okay, child 1 again. Child 1 again. We have to check. Now 6 here. Then plus 10 if you are adding your 16. So then your plus 11 if you are adding 27. 27th children here. Again that ring goes to the 27th children. Next year plus 12. So 39th children it goes here. Now plus 13. 13 means again 40 plus 12. So therefore 12 here. 12th children. Then plus, okay, 14. So 26th children. Next year 15. 40 goes. Then again it comes back to the child 1. So how many sequence we have done here? Okay. How many such a changes will the ring in the hands of the child 1? Now try to understand including child 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again comes here. So therefore 15 times it takes to come to the child 1 again. So the answer for the question here is 15. Got it? Don't mark as the 16. How many passes it has made? Okay, 15 passes only made to come back here. Okay, very important one. Please note it. So therefore 15. So this question we have done already. Next year. Here. We have done now on that wooden box. Okay, getting the price. Same kind of question here. The flag has to be designed with the 4 horizontal strip. 4 horizontal strip. That's it. Using some or all the colors red, green and yellow. What is the number of different ways in which this can be done so that no adjacent strips have same color? So now try to understand. First strip, to fill this one, we do have the 3 colors. Suppose if you are using green here, you should not use the green in the next strip. So therefore we do have only two options. Suppose if you are using green here, you can't use the green, but we can use the red and yellow. So therefore 2 here. Right. So like this, the last one also having 2. How many ways means 3 into 2 into 2 into 2. So therefore all the job has to be done here. right? So 8 into 3 becomes 24. So the answer is 24. Getting? Simple question, but you need to learn some logics. That's it. Easily you can able to manage. But learning the logics are very important here. How to solve these things. Getting? Shall we move to the next question? Okay. Next here. There are four letters. There are four letters and four envelopes. So this question, how many of you noted we have done in our foundation? So these questions are all present in your school books. I think for batch 10 and all we have done in the live class itself. Okay. For all the 10 batches. Whereas in the Asthivaram batch, we have provided you the recording. Okay. Now try to understand this one. Four letters. Letter 1, letter 2, letter 3, letter 4. And envelopes. So E1, E2, E3, E4. Now try to understand. Envelopes, and exactly one letter is to be put in the exactly one envelope with the correct address. If the letters are randomly inserted into the envelope, then consider the following statement. It is possible that exactly one letter goes into a incorrect. Incorrect. Now try to understand here. First statement, let us take here. First statement. Letter 1, letter 2, letter 3, letter 4. So this one, envelope 1, envelope 2, envelope 3, envelope 4. Suppose I am taking that the letter 1 rightly goes to the envelope 1. The letter 2 rightly goes to the envelope 3. Okay. They are saying that it is possible that exactly one letter goes into a incorrect envelope. One letter. No. Try to understand. This can be goes here, this can be goes here. You can't say exactly one letter goes into the incorrect envelope. Here, two letters also can goes into a incorrect envelope. Getting a? They are mentioning as a one letter. Exactly one letter. No. What they are mentioning is all the three goes in the right. One only wrong. That is not the possible case here. Exactly that word is wrong. Okay. Two letters also can goes into the incorrect envelope. So therefore statement 1 is wrong. Okay. Now next one, let us move on here. Now try to understand, this one is a very important thing you need to understand here. Okay. There are 6 ways in which only 2 letters can go into the correct envelope. Which of the following statement is or are correct? Okay. How many letters are there? 4. 2 letters goes into the right. So now how many possible ways are there? 4 into 3. Right? Divisible by 1 into 2. Cancel this one. 2. So 6. They are mentioning correct. There are only 6 ways. So second one is right. Now try to understand. The answer is B. Okay. Now understand this part here. Let me tell you that elaboratively with the statement number 2. For example, so let us take this one. First one goes in the right envelope. Second one not goes into the right envelope. The third one goes into the right envelope, which means envelope 3. Okay. So this one not going here. Okay. So 2 envelopes, right? So therefore here you can make it here. Then the first one goes in the right envelope. Okay. The second and third not going here. Then the fourth one goes here, right envelope. The first one not goes. The third one not goes. Sorry, fourth one not goes. The second one goes into the right envelope. Then third one goes into the right envelope. Okay. So like this you have to make here. So when you are doing with the first case, then we have to go with the second case. We have to check your, okay. So these and all lengthy process when comes to the examination. Just know this idea. 4 envelopes, write here only 2 letters. Therefore 4C2 you can take your, you can use NCR formula also. NCR is equal to n factorial by r factorial into n minus r factorial. Suppose if you don't know means how to apply that one. You have to move 2 places from 4 in the numerator. 4 into 3. In the denominator, what you have to do? You have to move, okay, from 1 up to r. R here is what? 2. So therefore 1 into 2. So like this you can use. Getting how to use these things. But these things and all, if you are doing in the examination all, means there is a possibility to make a mistake. If you are making simple one mistake means surely it will affect. So therefore don't do such a mistakes here. Okay, it's a time consuming process. We have done in the foundation, that book I have explained here. There they have done here with the C1, C2, C3, so like that. Then envelope 1, envelope 2, envelope 3. Then we have done these things. So this and all not required here. Okay. If anybody having doubt with this question, you can ask, or else mark the slide number. I will address the doubts after completing the last question. Now, this is a very important question. Yes, possible that to make a mistake with these questions. Okay, first time when you are seeing this kind of questions, surely there is a possible to make a mistake. Now, Raj has 10 pair of red. Red here is 10. White here is 9. Black here is 8. Okay, pair of shoes here. Now try to understand pair. Pair means how many here? So pair means here 20, here 18 shoes, here 16. The total here is how much? 54. Okay, so out of this 54, read it carefully. If he randomly picks shoe one by one without replacement from the box to get a red pair, so this is very important, red pair of shoes to wear, what is the maximum number of attempts he has to make? Maximum number of attempts he has to make. Now try to understand the same concept we apply here. So here 20, right, here 18, here 16. We need to focus on the red, so leave that red. All are coming with the black and the white. So in the situation, how many attempts he is doing here? 34 attempts he is doing. Now try to understand. Here 34 we are done here. Now 35th attempt onwards, surely going to be the red. Okay. Now try to understand here. The shoe has 2 pairs, which means 2 pair means 1 pair contains, sorry, not 2 pair, 1 pair contains left and right. 2 shoes, left and right. Now try to understand this question. If all the attempts, okay, all the attempt, so here 20, right, 20 red means surely 10 left will be there, 10 right will be there in that red. Okay, for all the attempts he is taking, all the 10 attempts he is taking left, all the left over, the next is going to be the right here. So 1. So therefore here 45. So the answer for the question here is 45. Getting how to approach this kind of questions? Okay, fine. Now let me conclude the recordings and I will address your doubts. You can ask your doubts. We will discuss the doubts and we will wind up. Okay, wait a minute.